So we have seen our PPT about about what is house wiring and how many phases we'll have. So in this video, you'll have a clear idea about what is a single phase and what is a three phase, what are the differences and where they are used. So have a clear watch of this video to understand better about the single phase and the triple phase. Okay.
Clearly understand the difference between three-phase and single-phase power, and you will also get the idea why three-phase power is preferred over single-phase. So, without wasting much time, let's get started. To understand the concept of three-phase power, we first must understand the single-phase power. So, consider that we have a generator with one winding which has two terminals A and A1, and a permanent magnet which is rotating inside the generator and which is driven by some external source like turbine. When this magnet will start rotating, a sinusoidal voltage will get induced across the terminal of this winding. By the way, if you want to know why only the sinusoidal wave is generated, I have a separate video on that. You can watch that video to get more resistor across the terminals of the winding. The resistor will start taking current, and if we draw the waveform for current, it will look like this. And we'll find that current is in phase with voltage. In phase, it simply means that both, that is voltage and current, start at same time, reaches their peak at same time, and gets zero at same time. Now, to get the instantaneous power, I'll simply multiply the voltage with current, and the resultant power waveform will look like this. This point is my peak power point. That is, power at this point is highest. The funny thing about single phase power is that the average power is one half of its peak value. You can do the math and find that if peak power is 2P, then the average power is P only. And also, the power output is not constant. Now let's say, using the previous single phase generator, I added one more winding with terminal B and B1. Please note, the winding B1 is displaced 90 degree from winding A1. The interesting part of this arrangement is that when the magnet is in the position shown, voltage across winding A1 is maximum, or we can say it is at its peak. And voltage across winding B1 is almost zero. This is because the flux only cuts across the terminal in slot A and A1 at this instance. So of course, when the magnet will rotate by 90 degree, mechanically, the voltage across winding B1 will reach its positive peak, and the voltage across winding A1 will be zero. Therefore, we can say that these two voltages are out of phase by 90 degree. This simply means that one voltage will reach its peak before 90 degree than the other. Now let me connect identical resistor across both the winding. Current IR1 and IR2 will start flowing through resistors. These currents are in phase with their respective voltage, and hence they are also out of phase with each other by 90 degree. The instantaneous power of both the resistor is as shown. Here you can notice that when the power output of resistor R1 is 0, power output of resistor R2 is maximum, and vice versa. If we add instantaneous power of both the phases, we will find that the resultant power is constant and equal to the peak power Pm of one phase. Now you might have already got why we use three-phase power, but still, to make things more clear, we'll have a look at three-phase power. Again, consider our two-phase generator, but this time we'll add one more winding, C1, and we'll place these three windings 120 degree apart from each other as shown. When the magnet will rotate, an identical voltage will get induced across all the three windings. As we have placed winding 120 degree apart from each other, the voltage induced in three phases will also be out of phase by 120 degree. Or simply, each voltage will reach their peak value after 120 degree. Let me make things more clear. When the magnet is in the position shown, voltage across winding A1 is maximum. When the magnet rotates by 120 degree, the voltage across winding B1 is maximum. When magnet rotates by 240 degrees from its initial low, here we have achieved constant and more power by simply adding two. Hence, they are all is constant and it is 1.5 times the peak power of one phase. So here we have achieved constant and more power by simply adding two extra windings to single phase generator. And this is the reason why three phase power is more preferred over single phase power. So to summarize this topic, the single phase power output is not constant and the average power is half than its maximum power. Two phase power output is constant at every instant and the average power is equal to the maximum power of one phase. Three phase power is also constant at every instance and the average power is 1.5 times the maximum power of one phase.
So I guess this video has given a clear idea about single phase, dual phase and triple phase. With this, I'll end this video. Thank you for watching.